we welcome to the almost the last portion on the number system here. The last one we will be taking up the exponents with rational power. Everything else, the laws of the exponents, they remain though the same. We take up the first few questions, which are the simple application. Like suppose I'm writing, let me take a positive part first. That means we are finding the third root of 64. Now that gives you, doing this is always better when you try to find out whose third power is 4. So it is 4 cube gives you 64 and the power outside remains same. If you recall, in the laws of exponent we had discussed how a to the power m into n gives you a to the power m into n. So that makes here 3 to the power 3 into 1 by 3, that makes it 4 to the power 1, that's 4. Same thing we can do with a negative rational power. This in itself means it is 1 by 125 to the power 1 by 3. We now also look into the fact, it is 1 by 1 upon, let me just make it reciprocate first, so that would look like 125 to the power 1 by 3. So either you directly find the cube root, or you can simply write 5 to the power 3 to the power 1 upon 3. 3 would get cancelled, so the answer becomes 5. Same kind of negative power we can take with a fraction, with a negative rational power. We need to reciprocate to remove this negative, so it becomes 25 upon 64 to the power 3 by 2. Now how do we solve this? We have to find out, we need to try and look how 2 is getting cancelled. So bracket within will try to find out whose square numbers are 25 and 64. If I think correctly, it becomes 5 upon 8 square, and then the outside bracket becomes 3 by 2. Thereby this becomes m and n in the formula, so this gets cancelled. It is 5 by 8 whole 3, so that makes the answer 125. 8 is a 64, 64, 8 is 512. These are the basic applications. Now we will learn about some simplifications, more on combination questions. I started here, no space, with a root power. All the next few questions, 2-3 questions, I'll be taking with root power. A basic one becomes like this. Take one step at a time. Remove the negative first. It would mean 1 by root 4 to the power 3. Writing root 4 is equivalent to writing 4 to the power 1 by 2, and here it is 3 power. We can though interchange and write it as 1 by, because it's, if either you find the root of 2, the root of 4, that would be 2, and then 2 to the power 3 would give you 8. Otherwise, as because we can, or you can take it as 4 to the power 3 and 1/2. That would also give you 4 4s are 16, 16 4s are 64, 64 to the power 1 by 2, that means it is half, that is 8. Or here you can directly make out, or maybe I would say directly from this step you can make out 1 by 4th root over of 4 is 2, 2 to the power 3, that would also give you some 1 by 8. Let us move on with 1 by 4 to the power minus 5 third root. How do we do this question? take one at a time. This is equivalent to writing root over of fourth root 5 and this third root. When we are writing so, if it is third root degree, then I will not write it this way because I have removed that root and made this 1 by 3. This would make it 1 by 4 to the power minus 5. Yeah, it was minus 5 to the power 3, or I can directly write it here as 5 by 3. This is negative, that means it's again needs to be reciprocated. That's 4 or 5 by 3. I can simply write it like either I find a cube root or I can write it as this one. How can this be written as, see what is 4 to the power 5's cube root? We can take it that way. 4 to the 16 will be 16 into 16 will be some 256 into 4, so that is 1024. 4 to the power 5 and 1 upon 3 if I'm trying. So this is giving me 1024's cube root. So 1024's cube root will be difficult to find, or we can separately write this as in exponential format. The answer, because I think the question reads as removing the radical signs and wherever and remove the negative indices, that is it. So we can write this as 2 to the power 3 plus 3 to the power 3, that would make it 5 to the power 3. Thereby I can write 4 to the power 1 plus 2 to the power 3. This is what? This is a to the power m minus m plus n, sorry. So this can also be written as a to the power m into a to the power n. So it is a to the power m into a to the power n. This can be the answer. Okay, we take up one on similar note again with a simplification this time. It's root 4 to the power minus 7 root 2 to the power of minus 5. We need to solve this, as because this is in square root, so I can write 4 to the power 1 by 2. Oh, this I can write inside the bracket though. 4 to the power 1 by 2, and outside it is a minus 7. Here also I do the same thing with a minus 5. This means this has to be reciprocated with my negative powers. So that would be 1 to the power of 4 1 by 2 whole 7, and this becomes, or I can give it a common denominator, so it is 2, not common, it has to be multiplied, so I write it like this, removing the negative powers. That means what? 4th root is 2, so it is 1 by 2 to the power 7, and here 2 root, that is quite will get into decimals, so I can simply write 2 to the power 5 upon 2. Now I can just write 1 by 2 to the power 7 into is 2 to the power 5 by 2. If I need to cancel, if I write 2 whole 1 by 2 in the numerator and write the same in the denominator, what do I get? Because, and then I'm getting 2 7 plus 1 by 2 plus 5 by 2 means this if I do 7, I'm doing a rough count here. I'll erase this later. I'm getting a 2, so it's 14 plus 1 6, so it is getting 20 by 2. It is 10 power I'm getting if I'm adding the powers, so because the bases are all equal. I made for my convenience here, it is 2 whole 1 by 2. The answer can also be a little different, then also it is acceptable. I move on with more questions. Here question is to find out 625 minus 1 by 4. That seems to be quite simple. It is 2 to the 625 to the power 1 by 4. I think it's 5 to the power 4 gives you 625. I write it 5 to the power 4 with 1/4, and that answer becomes 1 by 5. It sounds quite simple. We take up one which is a little different to this one. I write it x to the power minus 2 by 3, then y to the power minus 1 by 2 whole square of this. Let's see how we do this. This means, if you remember, a to the power m and b to the power n and the whole power, that means a to the power m square, m to the power n square. Okay, I do this as, this can be written as, because they have a common power, this can be separately written as x to the power this whole square with a y to the power minus 1 by 2 to the power 2. That means what? I can multiply this 2, so it is minus 4 by 3, and if I do this, I'm getting y to the power minus 1. This can be written as y to the power x to the power 4 by 3, removing the negative part, and here also I can write a minus. This was not much difficult though. Now comes the simplification part of this exponential rational exponents. Let's try and take us first one here. I can make some space. Here I write the first question, which reads as 25 to the power 3 by 2 into 243 to the power 3 by 5 whole by, we have to simplify this question, 5 upon 4 sorry, into 8 to the power 4 upon 3. Doing so, if I need to remove this 2 in the denominator, I need to express 25 in terms of square of 5. Even what I feel is 243 will be 3 to the power 5 here, as because I wanted to remove the 5 in the power as denominator. Similarly, 16 is 2 square, 2 is 4, thereby that will get cancelled, 4 again, and 8 is 2 cube, so thereby that will also cancel 3. I'm cancelling all the denominators, so I get 5 to the power 3 with 3 to the power 3 by 2 to the power 5 with 2 to the power 4. 5 to the power 3 is 125. 3 cube becomes 3 3 is 9, so 27 by 2 to the power 5 with 32, and this would be 16. If I multiply the numerator, I get 3375 upon 512. We take a few more questions in the next few sessions. Thank you.